Welcome everybody. Ein herzlich willkommen an allen. Bonjour à tout le monde et bienvenidos a todos. Entonces, today we are going to present you MIA system. The presentation will be structured in 3 parts. The first part, basic concepts that lead us to the development of MIA system. The second part, the field devices and the software that compose the system. And at the end, you will have the occasion to ask us all the questions you need to have, for which you need to have an answer. And we kindly ask you to fill in a survey just to let us understand if we have satisfied your expectations. So let's start. I will share my video. Okay, so our AGL monitoring and control system. First of all, as I told you before, we will start from the basic concept. Just think about a fire alarm system, and you will never power the fire alarm system on the same cable that gives the alarm data. So starting from this basic concept, we have developed the monitoring system on separate cables because the system that controls cannot be the same of the controlled one. Lights always on. Our system and generally speaking, monitoring and control must not affect the light's functionality. We shall change our mindset because what has begun as a maintenance purpose now is a safety purpose. So lights must always be on. Then the key point of our system, the integration. We can integrate to existing infrastructure, to existing lights and CCR units already installed. This allows the airport a really easy rehabilitation. And we are not tied to a specific light producer. So we invite you to abandon some false beliefs about optical fiber. The truth is that optical fiber does not use frequency to send data, so we do not have interferences. On the other hand, power line communication needs from 100 to up to 200 kilohertz. We do not have any issue connected to isolation loss. So we do not need any dedicated conduit, any dedicated pipe to lay down optical fiber. That's why we can place the optical fiber cable, we can lay it together with the primary cable and high voltage. We do not suffer low isolation. We do not need the 5 mega ohm of isolation. Of course, optical fiber cable is protected by a double rubber covering sheath, let's say, and an optical armoring, a glass armoring, sorry. So it can be also laid down in the ground without any conduit necessary. So how works MIA system? So you see here a layout. Here on the top right, MIA system, the software in control tower. Then you have GPI, which is our general purpose interface. And here in the layout, they are connected to CCR units, but it is an interface, so we can use it to take analog data and convert them into digital ones from secondary service as well, for example. The module MCLO, the monitoring module, and CDU here placed and installed to prevent runway incursion and to manage lead-on lights. We will start talking about the field devices. So MCLO, it is a monitoring module. I forgot to say you this. We will talk about our main case history because it is the most complete system we have installed in Venice, which is an airport in CAT 3B. And the experience has forced us to engineer a product, a really sturdy device, and a product that faces really a stressing environment, because as you probably know, under Venice Strip, there's seawater. So we have faced lots of environmental problems to manufacture a really sturdy device. So the monitoring module, it is IP68, not just the case, the connectors as well are melded and are optical connectors that engineered specifically for this product and for some military applications. Low consumption. You probably know that actual monitoring modules consumption goes from 15 watt up to 25 watt. Our module hardly reaches 1 watt consumption. The speed, of course, we use optical fiber, so the speed is 230.4 kilobytes per second. The communication range can be from 1 meter up to 3 kilometers. And we connect to the lamp, so with the FAA standard connector. That's why I told you before about our integration feature, because we use an FAA standard connector, so no matter which is the light manufacturer. We can control from 1 up to 5 lamps, but at the same time, we can control the single lamp and monitor the single lamp of these 5 connected. We have a wide range of modules. You can choose from a separated power supply or the model with a CCR power supply. We do not use a frequency, so we are interferences free, and we do not have any positioning limits within the manhole. So this is, as you are seeing now, plug and play connectors. These are our connectors to really make installation and maintenance easy, because we have experienced the field and at night staying in the manhole full of devices and cables, and you do not to get crazy to connect the device. We have really commit ourselves and really on this kind of module, so that the company has decided to protect this product with a worldwide patent pending. And low consumption answers to the need of a green airport. If you can just count how many monitoring modules you have on a 3 kilometer strip. About our connectors, they are pre-melded and they have a bending radius of 15 centimeters. So there are no issues about installing them. So how the system works. As we have already said, optical fiber communication. So we have 0.7 seconds of alarm to alarm in tower, interrogating 1,725 modules contemporary, and contemporary, they answer to us, to our system, and we communicate an eventual alarm of burnt lamp in tower. We can transmit, of course, a huge data amount. For example, the current passing through the transformer and from the transformer to the lamp. We can calculate temperature. We can also calculate the expected lifetime of the lamp. It is easy maintenance and installation. The firmware can be uploaded by remote. The modules are self-addressing, so you will never see people programming and uploading the firmware on the street. Of course, this kind of communication, of redundant communication, answers to the main international regulations, FAA, EASA, ICAO, so they are more than compliant. The forward and reverse communication makes the system a fault tolerance one. That is to say, we can recognize, detect the exact malfunction in light, the exact model that it is not working, and the exact point of an eventual cable failure. So now I will show you just a layout to let you understand how the communication works. It is really simple. We go forward and reverse. The communication goes from the first module to the last one, and then from the last one to the first. In this way, as you can see on this layout, we control 5 lamps. This is just an example of a 10-module channel. And the first module and the last one, they are installed in the same manhole in the first one. And probably this second layout will show you as well the convenience, also from a spending point of view, because we have on your right side our MCLO 5 monitoring 5 lamps with 1 transformer, but keeping always the individual lamp monitoring and control. On the left side, the traditional monitoring system with 3 modules, because we know that maximum with power line we can control 2 lamps. So we have 3 modules, 3 transformers to control 5 lamps. So, and how we can declare, how we can state that we have just 0.7 seconds to alarm tower. We have developed a measurement instrument. We used it, for example, during ENAC testing just 1 week ago in Venice. And this kind of instrument can calculate exactly the time we need, the time that AEL CMS needs to detect the burnt lamp or a failure. This instrument has been developed from our company, has been certified by an independent body, and of course it is it can be used to test the quality of any kind of lamp, any kind of AEL CMS. We have a standard FAA connector to connect to the lamp, and of course the standard connectors to connect to the PC. The advantages, really easy. We are immune to human responsiveness. If you think the time that human beings need to stop the clock, to stop the recording, or just to close and open your eyes, these are milliseconds that we lost in the calculation. So that's why we developed this measurement instrument. So let's go to the second slide, and probably if you are interested in the survey, we have also written a question about the LTC, the lamp time control. If you would like to receive more information about it, we can go deep on the next webinar. So we were talking about MIA system, specifically field devices. We have seen the monitoring module MCLO. Now we will show you the features of CDU, crossing detection unit. Again, it is a really sturdy device. It is screwless with snap lock, so that we can avoid spreading metal parts on the strip, which is not nice. It is small. It is mounted on a pole with a breaking joint. it is IP68, both the case and the cable glands. Again, low consumption. Which is the difference? The difference is that we do not use microwaves. So we have no interferences. We do not have a really high consumption, and it is safe. So no matter which are, for example, weather condition. So with the fog, snow, rain, no problem, because we use magnetic loop. These magnetic loops are installed 2 before and 2 after the stop bar. In this way, we can recognize the metal part of the aircraft, we can recognize eventual vehicles passing through, and we can also detect their direction and speed. Afterwards, I will show you exactly the point on the layout of our software. Of course, we are free from false alarms. Then here is just a picture, our colleague connecting the unit. And another advantage, considering the comparison with microwaves, is that we have calibration just once in the life of the CDU at the moment of the installation. Here is the last field device that we decided to present you today. Of course, we have a complete range to install the complete AGL monitoring and control system. This is the general purpose interface, our GPI. It has 16 in and 16 out optically insulated. For analog, it is IP67, and it is a low consumption device. It can be connected to any kind of CCR. The EEPROM is editable through a front connector, and it has also a high-speed communication. Now you see the CCR working together with our GPI interface. And we can go to the next step, which is the presentation of our software, our AL-CMS. Our colleague. Okay, so the advantages of MIA AL-CMS. It is a tailored software. So we have enough flexibility to design the management services required. We can manage also secondary AGL services. We can interface the ground radar if you want. And how we can do this? We are not a PLC-based software. We are a PC-based logic. So, of course, that gives lots of advantages. For example, installing the software on a laptop and test the AGL software directly on field. Taking, for example, the control of the commands of the control tower. Of course, this gives advantages also in the development of the software, upgrading it by remote, or changing, for example, the viability of the taxiway. We used this kind of feature a lot during Venice installation, for example. We have always worked at open airport, so probably this is a benefit that the airport can really appraise. So, again, redundant communication, of course, so we are in compliance with FAA, for example, AL890, and it is the software which is available and suitable for all kinds of airports, no matter the size or the category in which they are. So here is a video of our last quality testing. So you see the incredible responsiveness of the system. We have, as you can see on the laptop of my colleague, we are on board of our car. We are testing the system, and we have the command of the control tower. This is how we manage and command the CCR in the substation. You have seen the color switching in the layout of the screen of the monitor of our PC, and immediately the CCR have been switched on. These are some layouts about our software. This is one layout of the tower, with all the services, with the steps of the light, of a flash, PAPI, and so on. I will show you as well a layout of the status of the lamps, and subdivided into, this is the request of this customer, grouping them, they are in groups according to the circuit they belong, and so to the substation they belong. And here underneath you can see these black dots, which are the CDU communications, the positioning that I was telling you about, directions and speed. So when a vehicle is passing through, or an aircraft is passing through, these black dots becomes green, and they follow the aircraft or the vehicle moving. This is our simulation. The simulation is, this is our simulation post. We can simulate the software. It is used for many purposes. The first purpose, to test the changes we upload on the customer software, to organize the operator training, the airport operator training, and it is simulated on the real customer airfield with the emergency services, the tower screen, and so on. So, as I promised you before, our most complete case history, 1,725 monitoring modules on 28 channels. You see 50 CDUs. We have 3,450 optical connectors, and you probably are asking yourself, yes, but when and for how long have you tested the installation? The quite long time. It has been installed, the first part, in June 2018, and the main runway in July 2019. And so we tested with the ENAC just the 1st of October. So we are at the end of our webinar, well, of my presentation. Then it's up to you to ask all the questions you would like to receive an answer. And we would like to highlight the airport advantages we satisfy with our system. So low and easy maintenance operation, no additional infrastructure cost. Since we have low consumption devices, you do not have to think about how many CCR you need more, or if you have to calculate additional power supply. Safe. So we offer a reliable technology. We are in compliance with international regulations, and the airport does not risk to lose their category in LVP, in low visibility procedure. The upgrade is made by remote, so we can work at open airport, and it is available, the software is available on portable devices, so you can manage your maintenance activities in a quicker and easier way. So I thank you for your attention, and I kindly ask you to use the button question and answer to, I see probably there's already a question, and at the end of our meeting, I kindly ask you, remember if you have time to fill in the survey. So, let's see the questions. I forgot, of course, I have here beside me our precious technical director, so he will help me in answering to your question in the most proper way. So, okay, let's see the first question. Yes, Pablo, we have around 10 airports. They are at the moment all Italian airports. We can include in our references also 2 military airports. And yes, they are suggesting me in Venice. Venice is the only installation based on optical fiber. And anyway, we have published our references on our website. What are the rating and type of CCRs? Well, we have interfaced OCEM, OCEM CCR, ADB CCRs, and GRP as well. So the important feature is that they should have a multi-wire connection. That's the only feature required. I see you. Yes, sorry, I was forgetting. Also AES, that's true, another CCR producer. I see, yes, good morning, Ank. I'm reading your question, so everyone is aware of the question. I see you connect up to 5 lights to one transformer. Yes, right? If this transformer fails, all 5 lights will be off. Is this a good idea? No. Yes, the connection is interlaced. That is to say, one module connects to one of the first lights, and another module takes the connection to the second light. So we integrate in this way. So we never depend on the same module and the same transformer. Thus, stackable option available for CCR. I'm sorry, I have to stackable, impilabili. Yes, the answer is yes. We have the stackable option. Okay, here is coming another question. You mentioned that one fiber loop can be up to 3. No. Okay, so the connection, the optical fiber connection between one module and another module can be up to 3 kilometers length. Then mi stanno chiedendo, sorry, I will translate, mi stanno chiedendo se possiamo allungare questa distanza, poi il resto è...
La distanza posso mettere 1000 moduli, cioè 3 km l'uno dall'altro.
Okay, so we can then place a length of optical fiber of 3 kilometers and then go forward, of course. I know. Sì.
Fagli un esempio. 10 moduli per 3 km.
Of course, Yes, yes, okay. So the optical fiber between the modules can be of 3 kilometers. So then you can place one module, 3 kilometers, another module, then 3 kilometers, another module. So we can go forward. Okay. Yes, the reason why they choose this solution is that they asked for the maximum, the maximum, let's say, safety. So this has been agreed. There's no particular technical reason since we use the interlacing logic. So it has been a requirement. There's also another reason. It has been a requirement of the tender. So up to now, let's say no one has offered a 5 lamp control module. That's why. Then have you done a cost-benefit analysis between your system and the traditional ones? Yes. The cost-benefit are related to, first of all, infrastructure costs. That's to say, we can use the already existing manuals and we use really few space to be installed in the system. Another cost benefit is the low consumption. Another cost benefit is the low maintenance cost, the forecasting of lights replacement or the expected lifetime of the lamps. So another cost benefit is the management of a high traffic volume because of the follow the green if you use our CDU. Any light limitation are therefore just a second. To answer this question, I have to understand. Just a second. So lights limitations are there for SLCM circuits with CCR. Actually, no. That's to say that if the module is powered by the CCR, of course, we have to follow the CCR circuit power supply. So that's the limitation. Where do you put the insulation transformer? Just coming back to the question bar knee, there's no limitation on the other side if you have a separated power supply, of course. If you are power supplied by the CCR, we have the limitation to follow the circuit of the CCR. Otherwise, we have no limitation. Where do we put the insulation transformer? Between the module and the light. Do you have a picture of a typical pit with your system installed? Yes, just let me take the picture. Okay, so I will share with you this picture just to show you the modules installed in a pit. I have also some picture. I can show you another picture instead, just to show you the kind of connection. And let me take just a second. I will go here in image webinar, and I'll show you, for example, okay, I can show you as well this picture. Okay, and this is an example. We have, of course, shoot the picture, the photo in our office, just to show you how it is connected and to show you the integration and the interface with any kind of AGL, of light, let's say. So let's go back, okay, to the questions. Just a second. So the next question is about, can the modules communicate in another way except fiber optic cable? Well, no, because this is the innovation we offer, because we know that on power line communication, you have to face lots of issues connected to interferences, isolation loss. That's why we have also patent pending, opened a worldwide patent on MCLO, because we think that power line communication, no matter which kind of monitoring you offer, you can offer intelligent light, you can offer induction detection of the monitoring of the burnt lamp, but at the end, the communication runs always on power line. And this is the system that we want to change. And this is the innovation we would like to bring to the public and to the market. Maybe, how do you detect false positive crossing the lane, car instead of a plane? It does not matter if it is an aircraft passing through or a car passing through. It is runway incursion anyway, no matter which kind of vehicle it is. So it must sound the alarm. The other, what can be considered a false alarm instead can be, for example, a pigeon passing through, and of course the pigeon is not recognized, and this will not, the alarm will not sound, of course. No, the MCLO is not controlled by the GPI. The GPI is an interface that is used to communicate and control the CCR units, for example, or to collect data from other secondary services and transmit this data, also analog data, to the software. We do not have any limits on the number of MCLO connected to the fiber, to the optical fiber loop. So countless is the answer. Okay, about the GPI, the GPI has 16 in and 16 out. So we have quite a good range of in devices that can be interfaced and signal that can come in. If the control module fails, to what mode does the lights revert to? The lights are always on, anyway. This is for a safety reason. As I said before, the concept is that the monitoring control system has the main purpose, not of maintenance as we have done in the past, but a safety purpose. So that's why lights are always on. With our software, you can also preset the brilliance level. So if you are in a country where the weather conditions are changing rapidly and suddenly, you can preset the software telling that when you switch on the system, the AGL plant, the brilliance level, the step must be already at 3 or 4, if you like, or 5 as well. Another difference, for example, that comes to my mind right now is that we can control the functionality of the lights at any step of brilliance. So we do not need to come to brilliance 3, to step 3, to exactly understand if someone is not working. So I have a question. Yes, we have a predictive maintenance system. That is to say that we can forecast, so we can plan and schedule the intervention, the maintenance operation, because we have an history of the lamps. We have an history archive of the lamps, which records for how many times the lamp has been switched on and at which level, at which brilliance level. So we perfectly know which is the expected life of the lamp remaining. That's why we say that this is a really great advantage for the airport. Because of course we can plan the maintenance operation, and most part of you for sure knows that airport is available for maintenance operation usually at night, so the time always runs over. So it is really important, and it is a benefit planning these operations. The overview of the system, yes, is the scheme of our product. I will show you right now before I will answer to the last question at the moment. Yes, security can be, of course, implemented and improved as a service. We are experts, of course, in video and data transmission, so this can be implemented. Thank you for this suggestion. Then about the overview of the system, I will show you directly on our presentation the scheme, the layout. Sorry, I was showing you before. Okay, I think this can be. Okay. Sharing the screen. Right. So let me open. Okay, so here you see, in order to answer about this question about the general overview of the system. So the control tower, the MIA system is the ALCMS software. It is installed, of course, in tower, and with different functions that we habilitate. It is installed in maintenance, it is installed in substation, it is installed in the emergency post. We have installed it, for example, with no operational function in the direction offices of the airport. So it depends on the customer requirements. We are really flexible on that. Then the GPI, the interface here is shown in the substation, for example. The MCLO installed on field, along the runway, along the taxiways, and the CDU with the magnetic loop. You see, 2 after the stop bar and 2 before the stop bar. Okay. I will stop sharing the video to answer to the upcoming questions. Can the optical fiber connectors be made on site, or is it factory melded? No, to avoid any kind of connection problem, the optical fiber connectors are pre-melded in our factory. So they are already tested. They are mounted, melded, resin filled, and tested, let's say, 3 times, usually before delivery. The answer, this is an interesting question, as all the others, of course. So the expected lifetime and the maintenance of the lamp can be recognized, can recognize also if the light has been replaced. And we have a database that we can, of course, share with the airport, and this database, of course, detect the position of the lamp ID, and also we can study statistics and diagnostic about the functioning of the lamps. Okay, so I hope I have answered it in the most proper way to all your questions. Here it comes another question. Okay, so the maintenance and the history of the lamps. So the database about the lamps and the functioning time of the lamp. It is then manually reset. Okay. Thank you. Thank you, Daniele. Okay, another question. Thank you, Filippo. Thank you all for coming. Thanks to you to being here and to participate to this webinar. It is really important for me to have your opinion about the webinar, about the technical level, about your impressions, and really thanks to you. It has been a pleasant experience. I hope the same for you. I hope also to have the occasion to organize other webinars together. In the survey, you will have also the possibility to ask for another webinar if you are interested in discovering more about the LTC, the lamp time control instrument. So afterwards, if you would like to share this webinar to the people that unfortunately couldn't be with us, I will also publish the registration of this webinar on our YouTube channel. So thanks for coming, thanks for your attention, and have a nice day, everybody.